Hello everyone. Now in this section, we would like to use a simple questions as an sample to let you learn how to calculate out the sampling distribution of the S-bar. In our question, it is what is the probability that a simple random sample of 30 applicants will provide an estimate of the population mean SAT score that is within positive and negative 10 of the actual population mean? In other words, such questions that would like us to answer is what is the probability that the S-bar will be between 60,187 and 70,107? That is, if today we know the expected value of the S-bar that is 1697, then we would like to know that is within positive and negative 10 scores of the such mean. So we would like to know the probability of the S-bar. Okay, so when we solve such question, the first one thing we need to calculate out is to notice its standard deviation of the sample. In such here is 50.96. So the first step we need to do is to calculate out the z-value at the upper endpoint of the interval. Because our interval is, we would like to know positive and negative 10 of the actual population mean. So our interval is from 6087 to 7007. So the first one thing we will to calculate out is the upper endpoint of the interval. So we will use the formula we learned before our midterm exam. That is z-value equals to the upper value minus the S-bar and divided by the standard deviation of the sample. So you will get the z-value is 0.63. So then you will need to use your table to find out the probability of the z-value that less and equal to 0.63. And if you check the table, the normal distribution table, you check that you will find the probability is 0.7357 here. If you calculate out the z-value, then you need to check the table to find the 0.63 to get the result. And that means the probability below here in such darker gray area, heavy gray area, that is the probability is 0.7357. So the second, the next step we will do is to calculate out the z-value of the lower endpoint of the interval. So we will also use the formula we learned before the midterm exam about the z-value. That is to use the lower value and then minus the mean of the S, that is the S-bar, and then divided by the standard deviation of our sample. Then you will get it became a minus 0.63. Then you need to check again from your normal distribution table to get the probability that is less and equal to minus 0.63. Then you will know the probability is 0.2643. That means the probability below 87 is 0.2643. So today you would like to know the probability between the lower and upper endpoint of the interval that we today would like to know. You need to deduct them. So you will use the probability that z-value less equal to 0.68 minus the probability of the z-value that is less or equal to the negative or 0.68, then to get the result that is 0.4740. So here you will find the probability to make such a result that in such interval is 0.4740. Then if we would like to ask another question, that is, suppose we select a simple random sample that is from 30 to 100, then if the result will be changed, because in such context, the sample size has been increased. So the expected value of the S bar U mu, it will still the same because it's equal to the population mean. So our total population is still the same. So the expected value of our sample is the same. That is, it will remain at 1697. But our standard deviation will be changed because we will make it from 30 to 100. So our sample size has been changed. And because this is an finite population, so you need to calculate it again. And then the n, the sample size will become 100, not the original 30. Then you will get the standard deviation of the sample is 8.2. But our previous standard deviation of the sample, that because our sample size is 30, so you will find the standard deviation of it is 50.96. So here you will find with the sample size increase, our standard deviation of the sample it will become smaller, and that makes the estimator that can be more close to the expected value of the S bar or the mu. So here, if the sample size is smaller, you will find it will has more width from its bottom. But if the sample size increase, the bottom of the shape will be narrow. So then we can recalculate it again following our previous method to know if today our sample size became from 30 to 100, and if the probability of the interval will also be the same, then we will find the results will be changed. The probability between the interval that is negative 10 and positive 10 of the mu, then you will get the result is 0.7776. So because the sampling distribution with n that equals 100, that makes a smaller standard error. So that makes the S bar that have less variability, so tends to be closer to the population mean than the value of the S bar that is when the sample size is 30. So here you will find in such a condition, if we make the sample size become larger, then you will decrease the standard deviation. That means the variance will be less, and makes the result can be more close to the population mean. So therefore, we can say as the sample size is increased, the standard deviation or the standard error of the mean that will decrease. And as a result, the larger sample size can provide us a higher probability that the sample mean is within a specified distance of the population mean. So that's our today's introduction. Thank you.